Hello students, now today we are going to start the topic that is a CMOS inverter. In this CMOS inverter, it is a basic, it is a complementary metal oxide semiconductor field effect transistor obtained by connecting the P channel and the N channel MOSFET in a series. Okay, this MOSFET is nothing but it is a metal oxide semiconductor field effect transistor which is in a series. We have to connect that transistor in a that is a P channel and the N channel. Okay, always it is connected in series. The drains are connected together and output is taken at the common drain. Input is applied to the common gate. Okay, whenever such type of the circuit has been observed by you. Okay, so the drains are connected together. These are the drains. This is the drain and this is the drain which is connected together for obtaining the output, and the output is taken from the common drain. It is a common drain. We have made the drain common and that's why the output is obtained like this. Okay. The input is applied to the common gate. This is the gate terminal of channel. This is the gate terminal of next channel, that is the P channel and the N channel. If both these are being get connected like this, we are giving the input that is indicated with a VI. In a CMOS, the P channel and the N channel, that is enhancement metal oxide semiconductor device, is fabricated on a small chip. Okay, that small chip is nothing but it is a one type of the IC, it is an integrated circuit. In that a small part has been fabricated. Okay, then the power consumption is negligible. As soon as you fabricated on small chip, the power consumption is negligible and the speed is limited by the substrate capacitance. Okay, the speed has been limited by the substrate capacitance. Here whenever you are using this particular the value for that particular thing, the SOS technology is used to reduce this effect. This SOS technology is nothing but it is a silicon on a sapphire, SAPPHIRE. Okay, SOS silicon on SAPPHIRE. It is a full form for this SOS. Okay students, it is used to reduce the effect. It is mostly used in the MSI and the LSI technology. This CMOS, it is used in LSI and the MSI technology. It is generally used. Now very first we are going to start the topic that is a CMOS inverter. This CMOS inverter is nothing but, as you know, the inverter, we have studied the inverter. This inverter is nothing but whenever any one input is low, you are getting the output as a high, and whenever the any input is high, you are getting the output as a low. The same function is being occurred by using this particular CMOS also. Here the CMOS circuit I have already drawn here. The first P channel, it is a P channel and it is the N channel. The P channel, first the gate, source and the drain. The substrate terminal has been given to you. Here also in the N channel, the gate, the drain and the source, that is the substrate terminal. The substrate is grounded. Here the source terminal is also given with a positive VCC, and gate of both the P channel and the N channel are connected in such a way that it gives you the input. Okay, the P channel drain, the N channel drain, both the drains has been connected in such a way it will produce the output. Okay, so it is the circuit implementation. Okay, it is very much important for you to understand this circuit. Before here, if we have used the transistor consisting of a 3 terminal. Okay students, it is consisting of a 3 terminal, that is a collector, base and emitter. By using this particular collector, base and emitter, we can also draw the circuit. Okay, but as it is a CMOS, it is a complementary metal oxide semiconductor inverter, we have to use this particular CMOS symbol, and by using this particular CMOS symbol, the P channel and the N channel, we have to connect in such a way that it will give you the output, and this circuit will going to be work in the inverter. Okay, so here as it is a channel number, it is a P channel and it is the N channel, this Q1, the Q1 and the Q2 has been assigned to you. That is, it is a Q1. Okay, Q1 gives you a N channel, and it is a Q2 gives you the P channel. The input is applied to the both gate. It is being get connected. The output is applied to the drain of both the channels. Okay, it is been get connected and make the common, and the output is obtained. The logical levels are 0 and plus VCC. The 0 indicates the logical 0 and VCC indicates the logic 1. When Vi is equal to VCC, that is Vi is equal to VCC, that VCC is nothing but we are applying here as a 1, or you may apply here, generally it is of a 5 volt, so we will say that it is a 1 or a 5 volt. So that at that position, this Q1 and Q2, the position for the Q1 it is in a on condition, and for the Q2 it is in a off condition, and that's why the VO is equal to 0. The drain current is very small, okay, since the transistor is in a series, and that's why that particular transistor is in series, and the output we are going to be obtained, it is 0. Okay, so when we are applying the input 0, the Q1 transistor is off and the Q2 is on, the output is 1. With a very small drain current, the product of the output leakage current and the VCC is quiescent dissipation. It is very low in any state, about a 50 nanovolt. Okay, so it is a very small explanation. Now for obtaining the input value, what is the input value which we are going to be applied to this particular gate? It is nothing but it is either 1 or either 0. Okay, this input, that is we have applied to the A terminal, we will write here as Vi, or just you may write down here Vi or A. We will apply the input that is 1, or we will apply the input that is 0. Okay, according to this one, Vi is equal to VCC, means Vi is equal to VCC, that is a 1. The output which will be get obtained, that output is nothing but it is indicated by V0 or Y. V0, or you may write down in the bracket, that is Y. As you know that it is an inverter, means the inverted value will be get obtained, so here you may write down Y is equal to A bar. Okay, so for this one, the VCC, I told you Q1 is on and Q2 is off. Since VO is equal to 0, means output is 0, and that's why you write down here as a 1. When we are applying 1, the output is 0. But as soon as we apply the input to the 0, the Q1 is in the off and Q2 is in the on condition, and that's why the output will be 1. Okay, since we are getting the table like this. Okay, students, it is very much important on your examination point of view, because without this table the answer doesn't complete. Okay, our next topic, that is a CMOS as a NAND gate. Okay, in this CMOS as a NAND gate, this is the circuit which indicates the CMOS as a NAND gate. Now in this particular circuit, you have the transistor Q3, Q4, Q1 and Q2. Okay, students, it is very much important that this is a Q1 and Q2. It gives you, it is formed, it is formed by combining the inverter circuit. This Q1 and Q2, it is formed by combining the inverter circuit. Okay, students, the 4 metal oxide semiconductor has been used. Okay, out of these 4, the 2 are N metal oxide semiconductor, that is a N channel, and rest 2, it is of a P channel metal oxide semiconductor. Okay, students, so which are that particular things? The N channel NMOS drives Q1 and sorry Q1 and Q2 it is in series, and PMOS drives Q3 and Q4, Q3 and Q4, okay, which is connected in parallel. It is connected in parallel, okay. These are connected in series, and these both are connected in the parallel. That is a P metal oxide semiconductor, P channel metal oxide semiconductor. It is a P metal oxide semiconductor, and it is a N metal oxide semiconductor, which is connected in series and it is connected in parallel. Okay. Now, for understanding the operation of this particular CMOS as a NAND gate, it is explained by using a truth table. It is explained by using that particular table. So we will directly draw the table. Before that one, you have this Q3 and Q4 or both. Okay, Q3 and Q4 or both, it is either the on, output is 1. Okay, when Q1 and Q2 on, the output is 0. This is the one thing it has to be predicted by you. It is keep in your mind. Okay. Now from the table we will understood that how it is going to work. So here you have the how many inputs. Here we will see the circuit. Here the Q3 and Q4 transistor, here Q1 and the Q2, it is connected in the series, it is connected in the parallel. From this particular gate, the A terminal has been taken out, and from this gate, the B terminal has been taken out for obtaining the input, okay, and the output is again connected from the drain, so that the output will be get obtained, it is indicated with a Y. Okay students, so now here how many inputs are there? There are two inputs with a name A and B. So here we will write down the input A and the B. Okay. So here what we will be getting the A and the B. Again, as the two input has been indicated, so 0, 0, 0, 1, 1, 0 and 1, 1. So here are the different 4 values we are obtaining. That is 0, 0, 0, 1, 1, 0 and 1, 1. And the operation which is going to be get occurred across Q1, Q2, Q3 and Q4, we will write here as a state of MOS, state of metal oxide semiconductor. Okay, how many conductors are there? Q1, Q2, Q3 and Q4. We will write here Q1, Q2, Q3 and Q4. Okay, so Q1, Q2, Q3 and Q4 will give you the for understanding this Q1, Q2, Q3, either it is in on condition or either it is in a off condition, that we have to see. And the output which is get obtained as it is a NAND gate. So at this particular instant you will be getting Y is equal to A dot B whole bar. Okay, it will be the output. Now in this particular, suppose the value that is A is equal to 0 and B is equal to 0. At that particular instant, the Q1 and Q2, this Q1 and Q2 both are in a off condition. As soon as it is an off condition, this Q3 and Q4 will be in a on condition. Okay. Then the output which will be get reflected, that is 1. As soon as the A terminal is 0 and the B terminal is 1, means A input is 0 and B input is 1, the transistor Q1, Q2, Q3 and Q4, it behaves like this. Q1 will be in a on condition and Q2 will be the off condition, Q3 will be in a on condition and Q4 will be in a off condition. and due to that the output will be again 1. Okay, when A is equal to 1 and B is equal to 0, you will be getting, here it is in off condition, Q1 it is in off condition, Q2 it is in on condition, Q3 it is again in the off condition, and Q4 it is again in the on condition, and at that you are getting the value as a 1, output as a 1. When both the input, that is A and B, are 1 and 1, means here Q1 and Q2 it is in a on condition, and Q3 and Q4 again it will be in a off condition, and that's why the output will be 0. Okay, so from this particular chart it is very much easier for the student to understand when it is in a on and when it is in a off, the output will be same as that of the NAND gate. We have to prove the NAND gate output, so for only this portion is very much important for you to keep in your mind for obtaining this 1110. Okay, no matter if it is not written by you, but in the examination the valuer wants this portion to be written in your paper. Okay students, once again, when A is equal to 0 and B is equal to 0, up to A is equal to 0 and B is equal to 1, A is equal to 1 and B is equal to 0, A is equal to 1 and B is equal to 1. Okay, at that particular condition, the values which you are getting, it is nothing but it is a table, that table which we have studied previous, that is a NAND gate table. In the formation, you are getting the output, that is 1, 1, 1 and 0. It is 1, 1, 1, 0. It is nothing but it is the complement of that particular AND gate. Okay, in the AND gate we are getting the value, that is 0, 0, 0, 1, 1, 0 and 1, 1. It is nothing but 0, 0, 0, 1. As soon as you complement the value, you are getting 1, 1, 1, 0. Means here A dot B whole bar, here it was a dot B. So this value we have proved. Okay, so it is the value which will be proved by this particular CMOS NAND gate. Okay, now in the next topic, that is our CMOS as a NOR gate. CMOS as a NOR gate we will see. CMOS as a NOR gate. Okay students, up till now we have studied the CMOS as a inverter, CMOS as a NAND gate. Now here we have to study the CMOS as a NOR gate. Now in this NOR gate, one thing you have to keep in your mind, that you have to produce the output, that is Y plus B, Y is equal to A plus B whole bar. This is the output which you will be getting at this particular NOR. Okay, so it is one of the prediction which you have to keep in your mind. Before that, we have to draw the circuit. The circuit is very much simple students. Previously we have drawn the circuit for the NAND gate. Okay, below there was a transistor. Okay, the transistor was a Q1 and Q2. Okay, it was in a series. Okay, now in this we have to keep that particular transistor to the upside. Now the circuit will look like this. Here the transistor, the gate terminal, here you give the A as an input, then the source. Okay, the drain and the drain terminal is being get connected like this. The terminal source with this output, here 1, 2 and 3, 1, 2 and 3, with a gate terminal like this. Here the first, this gate and this gate, it gives you the B, it gives you the B value, and here the A terminal. Okay, here the drain which is being get connected to the output like this. Okay students, and now here the output will be get occurred. So here y is equal to a plus b whole bar will be get obtained. Okay, this output is being get connected with this source terminal, that is a plus VCC, and here whole it is being get connected like this with a load like this. Okay students, so this and this terminal is being get common, and due to this one you will be getting the plus VCC, and this is being get connected to the output for y is equal to a plus b whole bar. Now this drain and this drain is being get connected, and the source and the substrate will be get obtained. Here it gives you the whole circuit diagram like this. Okay, now remain this terminal. This has to be get connected with this terminal as an obtaining the A input. Okay, here it is the A, and now this it remains. It has to be get connected with a terminal for obtaining the B input. Okay, so it is very much simple for you. Here the Q1 and Q2. Here we will say it is a Q1, and here we will say it is a Q2. It is in a parallel. Q1 and Q2, it is in a parallel. This Q1 and Q2 is nothing but, you may say that it is a NMOS. It is a N-channel metal oxide semiconductor. Q1 and Q2, it is connected in parallel. Now here the Q3 and Q4, it is a PMOS. Q3 and Q4, it is connected in series. It is connected in series. This Q3 and Q4, it is connected in series. Okay, the power required for this particular CMOS, it is up to 3 to 15 volt. What is power required? It is 3 to 15 volt, but in time we are giving here the plus VCC as a 5 volt. Okay, the output is high when it is compatible. It is compatible with TTL gate. Okay, now with the TTL gate, the output is high when both inputs are low, when A and B or both input is high, the output is equal to 0. Okay, as soon as the Q3 and Q4 is in on, you will get the value as a 1. For understanding this one, again we have a table. From the table, it is very much clear that you will be able to understand when it is in on and when it is in off. Which transistor will be in on condition, which transistor will be in the off condition. From the table, you will be going to be identified. So we will draw that particular table here. How many inputs are there? There are 2 inputs. So we will draw, for just wait a minute, y is equal to a plus b whole bar. Here the inputs which will be obtained, that is A and B, and the state of metal oxide semiconductor, the 4 transistors we have to write down, and the output you will be getting y is equal to a plus b whole bar. Okay students, for this one input, if the A value is 0 and B value is 0, for the first input 0 and 0, what will be the condition for Q1, Q2, Q3 and Q4? Q1, Q2, Q3 and Q4. And what will be the output? Okay, so when it is 0, 0, at that time this Q1 and Q2 will be in a off condition. As soon as it is an off condition, this Q3 and Q4 will be in an on condition. and since the output will be 1, as it is an output in on condition, directly the output will be getting, that is a 1. When a is equal to, when a is equal to 1, when a is equal to 0 and b is equal to 1, the q1 it is in a on condition and q2 it is in a off condition, q3 again it is in a off condition and it is in a on condition. Okay, since the output will be 0. If it is 1 and if it is 0, a value is 1 and b value is 0, the output which will be getting for this q1, q2, q3 and q4, again it will be in a off condition for the q1, q2 is in a on condition, q3 will be in a on condition and q4 will be in a off condition, and since the output will be 0. A is equal to 1 and b is equal to 1, a is equal to 1 and b is equal to 1, at this both the condition arises, this q1 and q2 will be in a on condition and q3 and q4 will be in a off condition. Both the transistors will be in a on condition and q3 and q4 will be in a off condition. It is the reverse case for this one, and since you will be getting output as a 0. So from this particular table it is very much clear that how the transistor is going to be work. Only you have to keep this transistor, which transistor will be in a on condition and which transistor will be in a off condition. That thing you have to keep in your mind for the understanding of the circuit. Okay students? Hello students, now we are going to compare the TTL and the Cmos logic family. Okay, in your examination the separate question is going to be asked, compare the TTL and Cmos logic family. Compare the TTL Cmos logic family. Okay students, so in this comparison what you have to keep in your mind, you have to keep the different parameters. Okay, that different parameters is nothing but it is a logic family. The parameter, or you may say the logic family, and here the TTL and the Cmos. TTL and the Cmos we will be starting. For first, the parameter which you have to keep in your mind for the TTL and the Cmos. First, the basic gate. What are the gates required for drawing this TTL and the Cmos? Okay, which is the gate for designing this one? It is nothing but it is a standard NAND, and the Cmos it is inverter. Okay students, Cmos it is inverter. Then the second number part, circuit. It requires a transistor logic. It is a transistor and transistor. In a Cmos you require a complementary MOS. Complementary metal oxide semiconductor. Okay, then the third number part which is involved, that is a speed of operation. The speed of operation, it requires for TTL it is more and for the Cmos it is less. Then the fourth number, the propagation delay time per gate. Propagation delay per gate. The propagation delay for that particular gate, it is up to 4 to 12 nanosecond for a TTL, and in this it is a 50 nanosecond. This 50 nanosecond I told you in a circuit diagram explanation. Then the fifth number, how much the nominal supply voltage. Nominal supply voltage required for the TTL, it is 5 volt, and CMOS, just in the CMOS family I told you, it is 3 to 15 volt. Okay, then sixth number part which is involved, the wired collector capability. Wired collector capability, it is having a passive pull up. For TTL it is a passive pull up, and for CMOS it is a tri-state output. Tri-state output. Okay, then seventh number part which is involved, it is noise immunity. Noise immunity for the TTL, it is good, and noise immunity for the CMOS, it is very good to excellent. It is excellent. Okay, or you may write down here, instead of using this excellent, very good to excellent. EXCELLENT, excellent. Okay students, now after this, the functions which is get involved in this, you will be getting the value, that is the functions which is involved in this, it is like this. The 8 number part, the available functions. For the TTL it is very high. And for the CMOS, the available function, it is only high. So it is the comparison in between the TTL and the Cmos logic family. In your examination, the separate question is going to be asked, and that separate question, it carries either the 3 marks, or you may get this as a 4 marks. According to that, you have to put the points. And here again, you have the one particular thing, keep in your mind, that you have to follow the advantages of the CMOS. The advantages of that particular CMOS. Here we will see the advantages. Okay, advantages of CMOS. The very first advantage for the CMOS, it is given by the quiescent or a static power. Quiescent or the static power dissipated is extremely small. Almost a few nanowatts. It is very much important. It is a nanowatt. Okay, nanowatt only. The next second number part, which is having the advantage for the CMOS, it is noise immunity is very good. Second number, noise immunity is very good. The third number, the fan out is exits 50. Fan out exits 50. Fourth number, the single power line is needed. Okay. Fifth number, the temperature stability is very good. Temperature stability is very good. Okay, these are the 5 points which you have to keep in your mind. It is the advantage for the CMOS. There are again 2 points there remains, but these are the very important point which covers the marks in your examination. Okay, if it is asked combined, then you will be getting the advantages for the 3 or 4 marks. Okay students, thank you.